Okay, so we're back again, and so we're going to use this time, we'll use our friendly green color to talk about pins not working. About a Z-score. There we go. So what do we use this for? So one, it gives us a value, right? And in and of itself, by itself, kind of tells us how far out something is. Out something is. And so we use this to give a weight to how unusual something is. It is standardized. Maybe this will be better for this screen. My handwriting isn't this bad on paper, but it is here. Standardized, so it can be compared across measures. Maybe that one would be better. And gives a sense of impact. So before we get into like why that is real quick, let's talk a little bit about how to calculate it, because it'll kind of make more sense once we talk about it. So if we look at back into our observation, right? So if we look here, we have a z-score, and this is going to be equal to an observation value minus x bar. So this is going to be the mean, recall, divided by the standard deviation, right? So we use this for individual values. And we can find out how extreme one value is. Okay, so how do we go about this then? So let's take a little bit and we'll use a chapter problem to solve here. So let's look, if you're using the 4th edition, this is going to be 2.124, and this is page 87. So in this problem, right, it talks about the WHO, and they're testing people for blood pressure, right? And so they tell us a few bits of information. One is the mean x bar equals 121, and the SD equals 16, right? So this information is going for, and so it says we have this new reading, so we have a reading of 140. So what the saying is, like what is the z-score? So what is the z-score? So for this particular problem, one, we're going to subtract the observation from the mean, divide by the standard deviation. So that's the z-score. So what do we do with this, right? So we're going to say that z is equal to 140 minus 121 divided by 16. And we use our calculator, which I will do right here. We get 140 minus 121. So this is going to equal to 19 divided by 16. And this is going to be equal to what? 19 divided by 16. And this is equal to 1.1875. So does this really mean anything? Like, do we really care? Probably not, right? This is within, we know from this, right, that looking at this, we haven't talked about this yet, but that's what our z-score is, right? So it's a pretty straightforward, easy formula to understand. And just for like fun, again, right? What do we do with this information, right? So let's do another one real quick. We'll do 2.125, and this is on page 87 in the 4th edition, right? It tells us that we have serial sodium where x bar is equal to 167, and the standard deviation is 77.3. So if we use, again, and it's asking us like, what is Z for a sodium value of 0? So that's what we're trying to figure out, right? So the way that we would figure this out is that we would take 0 minus 167 divided by 77.3. And this is going to equal negative 167. And the negative part here does matter because it tells us on what side to put it on. And what we come up with is, so we divide negative 167 divided by 77.3. We end up finding that this is going to ultimately equal negative 2.1604, 0.14, and we would round those to negative 2.16. So we did all this math, right? So like, what does this actually mean? Why is this useful? So because these are standardized units, right, and we're dividing by the standard deviation, it gives us a place. We know that you'll recall from the first video, right? So like 1 SD holds 68% of observations, and that 2 SD, 2 standard deviations, contain 95% of observations. And so when we look at this first value, right, if we look at the first one is 1.1875, we can say mostly normal, expected. So nothing crazy. It's just like, it is what it is. A little bit more than what we expect, but like well within expectations, right? But this value though of 2.16, now this is outside 2 deviations. And so what this tells us then, when it's outside of 2 deviations, this is a highly unusual value. And it's within like 5% of highly unusual. So when you guys like think about like when you took like an SAT or an ACT, it probably gave you like some percentile score. So you were better than 30% of everyone, or 45%, or 65%, something like this, right? What we're saying with this is that this is within like top tier, sort of. Because this top tier, right, this is noteworthy. And this may alert us to a problem or a solution. So this could be a problem, solution, or something like that. And so this should draw our attention. Because when we think about this like on a graph, right? So we have our graph again, and we go back here. That's maybe the best one I've had yet. We have, like 1 right here that is shown up here, and then we start getting into maybe like these 2s, right? Where we maybe think like, 68% fall here, the 95% out here. We're talking about on the negative side, right? That this is out here, right? So this is tail behavior. And super special. So when we think about the 0 sodium in this example, 0 sodium, this is like, wow, really odd from everything else. Something is up with that brand of cereal. So that's a way like to kind of think about like why those kinds of values are important, and they're really important in statistics, and it's something that we'll talk about maybe later. Maybe I don't think actually maybe we won't, but it's something to hold on to if you ever take future stats courses. But anyway, that's how we calculate it. It's pretty easy to do. Hope this was useful for contextualizing some stuff. So and then I'll talk to you.